My friends studying for classical mechanics, pay attention. I'm going to show you guys very quickly today how I would study for a test like this. I'm going to use the example chapter 11 from Sirui and Jowett, angular momentum. What I have written down for you guys here today is every single equation of importance. There's more equations, but these are the bulk ones, like the bolded ones, and more that are not bolded. Everything written here, just the equation itself. There is no names or anything like this. That's step number one. You have to do this because these equations are going to pop up. And I like studying with math because physics and math have a strong link, a beautiful marriage. You cannot do good physics without knowing a bit of math. And I like studying with the math because a lot of people find it a bit more challenging to learn. You know, the physics you can kind of say in a sentence, but the math you got to look at some symbols. However, you have an equation sheet with you in most exams. So you can study off of the equations, and when you see an equation and when you've studied with the equation should give you a picture of what's happening. You should see the equation and be like, I know what every single letter means in this. I know what it's related to. I can picture a problem. I can draw a picture related to this, everything. So you need to build your knowledge off of this math, and you're going to be very thankful for this. Also, if you just learn the physics and don't do the math, you're going to get stuck and unable to solve a problem. So here I've written every single equation, nothing else though, just the equations. Boom, went through the chapter 15 minutes, wrote down everything. Here are my tips for you guys. How to study using equations. Step number one, define every single symbol, the name of the symbol, the units, the meaning of the entire equation or the symbol. Have a picture in your head what the symbol is referring to. There's many pictures in the book. You could steal these, draw them, figure it out. And have a problem or several problems related to each symbol in each equation. Go through each of these, right? This is the first equation, angular momentum. The chapter is about angular momentum. Here, I don't know, is there anything about angular momentum? I'll tell you guys, this is an F. It looks like force to me. This is R. Normally we use R for distance. There is a cross over here, and these guys are both vectors. And there's this new symbol, tau. What is this? This is torque, this is distance, this is force. There is a cross product between them. What are the units? I don't know the units. I'm going to go write them down, write my notes over here, boom, and fill up this entire page so that every single equation has as much detail as I can physically put into it. If you run out of space, get a new paper. Here is some math, right? This C, A, B are general vectors to teach you about vector algebra, cross products, dot products. In this case, there's no dot products, but I'm sure you've seen in the previous chapters of classical mechanics some dot products. So some important stuff over here. I'm not going to really talk about this, but I'm going to refer you to a crazy video that I posted 11 months ago, vectors and their algebra. This is a crazy video. It's 40 minutes. Put it on 2 times speed. You're going to finish it in 20 minutes. This is the time it takes to finish one meal or take one big poop. Honestly, watch this video twice, 2 times speed. You're going to learn everything you possibly need about vectors. The important thing is, how do you work with vectors? How do you split them up into different components? How do you say which direction and stuff like this? How do you cross multiply vectors? This stuff here. It's very important. The chapter starts off with this, so you need to know how to work with vectors. My video will help you out, but still, watching a video is not going to do everything for you, so you have to do the rest of the stuff. Let's check number 2. Write each equation down and explain it. And then I wrote this thing here, explain the name of the equation. Does the equation have a name? It most likely does. If it doesn't, give it a name. Say this is the equation that talks about blank. Name the equation and get comfortable with it and try to remember it fully. The equation will have the symbols in it, right? So this is step number 1, figure out the symbols. Then start working one level above that, write the equation down. The meaning, the units in the equation, do the units check out. An equal sign means the units on one side are going to equal the units on the other side. So there's going to be some unit cancellation. If the units don't cancel, you have to see how to convert between units. Conversion between units is super important. I think literally the first chapter in Sirui and Jowett is saying units are important, bro. So figure out what the units are talking about, and then have a picture and a problem in your head for each equation. Each equation is going to have an associated problem in the book. If there isn't one, find one in the homework or find one online. Be like, yo, there's this equation in the book. Google search a problem related to this. Then check in the book and see which section in the book is this problem related to. Nice. Then we go to the problem. Solve as many problems as possible. There are many examples done in the book. They break down the problem. They say how to think about it, what equation to use. A lot of the time, this is one strategy of doing it, but there's different strategies because there's different equations. So solve as many problems as possible by yourself. If you don't know how to do it, go back to the book, check the solution. Read the solution 5 times, try to understand it, then do the problem by yourself. Wait a day, do the problem by yourself again. Do the problem, the same problem, over and over 5 times, 6 times. Do that for all the problems in the book. Start with the easy ones, the examples, they are solved for you. So do those because then you have the answer and you could check if you did it properly. Then go to the ones that don't have solutions. Like in the back of the book, there's infinite problems. Some of them are harder than others. You might be like, yo, I'm wasting my time. Do these problems, bro. You're going to be illuminated after you solve these. If you can't find the answer, Google search online. What is the solution to this problem? Boom, check the solution, read the solution 5 times, 6 times. Read it before bed, read it 5 times every day, 10 times every day. You're gonna remember it, I promise you. You just have to read it. You just have to spend the time doing it. Solve as many problems as possible. And still, this thing relates to this. Every time you solve a problem, ask yourself, what's the equation they use? Every time you use an equation, ask yourself, what symbol do they use? Ask yourself, what are the units? Everything here that I've written, boom, you need to ask yourself. This is honestly general for every class, chemistry, physics, whatever. So apply this to anything. Step 4 is repeat. Do this every single day, guys. Don't take a rest day from physics. It's not that hard. You have to do, I don't know, maybe one problem is going to be 20 minutes, maybe it's an hour. You don't have to do this. You could look at a singular equation and be like, what does this symbol mean? Google search the symbol, Google search the units, boom, write it down. That's 5 minutes. You can do this while just walking down the stairs. Boom, check your phone. YouTube video, what does this mean? Boom, and then you're done. You don't have to be like, I studied yesterday, I'm gonna take a break today. Don't do this. This is stupid. Study every single day, study every single minute, every hour. You're chilling. Obviously, mental health, hold yourself down, take rests and talk to family, educate or feed yourself, exercise a little bit. But don't be like, I studied yesterday for 12 hours. Study every day. Every single day, read the thing over and over and over. It's like in a video game, if you play a video game and you're in a map that's new, after the 5th time of playing that map, you're going to be like, I kind of know. But then after the 100th time, this map is like more known to you than your hometown, than your house. So repeat the same thing with physics. Eventually, you're going to understand what's happening and you're going to remember all these equations. You're going to look at these equations and be like, this feels comfortable to me. I can just read this and it just boom pops out of my mind. I can see a problem with each of these. To me right now, I'm a little rusty with it. So, some of these are confusing. So I'm going to have to do this and be like, what does this mean? So, you're not eventually a physicist and you know everything. You have to keep breaking the rust off of the gears and then, keep reminding yourself what's happening because people forget. And if you do things over, you're not going to forget. Then here are some extra things. Go through the book and recognize the equations. After you've done this entire thing and you feel comfortable with all the equations, read the book slowly and be like, what's going on here? Do I understand the equations that they're using? And, ask yourself, can I do all of this when I read the book? Can I identify the symbols, identify the equations? If I see a problem, can I predict the solution? Can I see it done in my head before they give me the solution? Try to do this if you have extra time. I know it takes a long time to read all this. You have 5 classes. But this is the important stuff, and this you can do fairly quickly. Going through the book, this takes a while. You sit down for like 1 hour, you're going to read like 7 pages of the book. One chapter is like 30 pages. So it takes a while. Obviously, balance your time, manage it well. You have many classes, so try to figure that out. Repeat example problems and the homework. The first problem you should do is the example problem in the book because they solve this, and this is an important problem that's probably going to get linked to other problems that are a bit different, but this is the bulk one. So start with the example problem in the book. When you finish all the example problems, check your homework. The homework is important because the professor picks specific homework problems that he's most likely going to put on the final. If you start doing other problems online, it might be a different class. They might have slightly different curriculum that's going to give you different problems. So first, do the example problems in the book, then do your homework, then do the problems at the back of the book, then do extra problems you find online. Do all of these problems if you have the time. If you don't, though, start with the top ones, example problems in the book, and then boom, work your way down as much as you can. But still do the problems as much as you can every single day. Test your memory. Right now, you've put a bunch of shit in your mind, a lot. Test your memory. Try to recall what you learned. If you just look at this equation, don't go in your notes and be like, what does this mean? Try to recall from your notes, what does this mean? What does this mean? What are the units? If you do repeated recollection, your memory will be strengthened. And then keep on studying. Check out my vector video. Let me know if you guys have questions. I'll talk to you guys later. Peace. Good luck.